Hi everyone, here we are, brand new lesson, right? So make sure you have paper and pencil out, ready to get started, right? So first thing that we always do is we recognize the name of the lesson, right? And the name of this lesson is called Properties of Exponents. So, properties of exponents, right? And what we're going to learn about the properties of exponents is there are 6 big rules. So the big 6 rules of the properties of exponents. Okay? So the first rule that we're going to learn is called the property of 1. Right? So let us highlight that. The property of 1. Now, this is called the property of 1 because whenever you have an exponent that's 1, x to the power of 1 is just x. Right? X to the power of 1 is just x. So, that means that anything to the power of 1 is that same number. Right? So what this is saying is that anything to the power of 1, actually, let me erase here. There we go. Anything to the power of 1 is that same anything. Right? So, for example, if we were to have y to the power of 1, that gives you just y. Right? Or if we had 23 to the power of 1, that just gives you 23, right? And if you had 52x with parentheses, right, to the power of 1, that would just give you 52x, right? So anything to the power of 1 is that same thing, right? Anything to the power of 1 is that same thing. Okay? So that was called property of 1. Next property we're going to learn about exponents is called the property of 0. Right? So what this property says is m to the power of 0 is equal to 1. M meaning any number in the world except 0, not counting 0, but any other number to the power of 0 is equal to 1. So, or any other variable as well. So if we have x to the power of 0, well, that gives you 1, comma. I can have 237 to the power of 0. Well, that gives you 1. Right? And you can have something fancy that has parentheses 200, let's change it up here, 489.46 to the power of 0, and that, everybody, is just 1. Right? So the property of 0 says that anything to the power of 0 is equal to 1. Right? So these are the 2 properties that are always there. Always there. Okay? Another property that is always there is called the property of negatives. Property of negatives. So the way this works is a to the negative n is equal to 1 over a to the n. So let me show you how that works a little better. So this, if I make this a fraction, right, and I say, give me a positive exponent, only want positive exponents, that means that this a to the negative n has to go down to the bottom now. See? It was on top of the fraction, but now it's got to go down to the bottom of this fraction and become a to the positive, right? So let me give you some examples here. So, for example, if you have 4 to the negative 1, and I told you, and somebody told you, I need that to be a positive exponent. So what you do is you put a 1 under it, right? And you make another fraction. And now this 4 to the negative n is going to go down here to the negative 1, and is going to become 4 to the positive 1. And here in this empty spot here, you just put a 1. Right? Let's do another example. Right? If I have 5 to the negative 11, and it says write in terms of positive exponents. Well, that has a 1 there. So I make equal to another fraction. That means that 5 to the negative 11 is going to go down here, and the negative 11 is going to become a positive 11. And this empty spot over here just becomes a 1. Right? See? So it goes diagonal. Look at that. It goes diagonal. Now, the same thing is going to work if it's backwards. Let me show you. Right? What if we start off with, let's say, 1 over 24 to the negative 8? Well, again, I make a fraction. Now, remember, diagonal, right? Look at that, diagonal down, diagonal down. But this time it's backwards, it's going to work diagonal up. So 24 is going to go up, and the negative 8 is going to become a positive 8. And this empty space becomes just a 1. Right? So, whenever you want to make something negative, you go either diagonal up or diagonal down, right? You go down or up, right? One more example here. One that's a little more complex. So let's say you have 3 over x to the negative 7. I write my line, right? So that means that, you see this 3 here? This 3 doesn't have a negative exponent. So this 3 is going to stay up here. It's not going anywhere. There's no need for it to move. But this x to the negative 7 is going to go up and become x to the positive 7. And we put a 1 under just in case. All right, there you go. That's the property of negatives, right? That's what we call the property of negatives. So we have the property of 1. We have the property of 0. And we have the property of negatives. Okay? So the first different kind of property we're going to cover is called the product property. So let us highlight that. This is called the product property. Does anyone remember what the word product means mathematically? In math language? Product, everyone, means multiplying. As you can see here in this example, a to the power of m times, multiplying, right? A to the power of n. Well, if you notice, this a and this a are the same. They have the same base, everyone. This is called the same base. So when we have the same base, kiddos, that means that we can take this m and this n and we can add them. Right? Let me show you how that works. Right? Show you how that works. So if I have x to the 4th times x to the 3rd, well, I have the same base, x and x. That means I could just write x one time, and I'm going to add my exponents. 4 plus 3. 4 plus 3. And that's going to give me x. 4 plus 3 is 7. Look at that. Look at that. That's how it works. Okay. Let's do another example. Let's change the color here. Let's do some orange here. It works with numbers as well. If we don't have letters, variables, it works with numbers. So I have 7 to the 25th power times 7 to the 11th power. Well, I have the same base, 7 and 7. So that means that 7, what I can do with the exponents is add 25 plus 11. 25 plus 11. That's going to give me 7 to the power of 36. Look at that. Look at that. Pretty good, right? Pretty good. So if I have the same base, I can put stuff together. I can add them together, right? Let me do one more that's a little bit more complex. So let's see, I have x to the power of 3 times y to the power of 2 times x to the power of 1 times y to the power of 11. It's a bunch of different ones, right? So what I'm going to do, watch what I'm going to do. I'm going to write everything that I know that's the same together. So my x is x to the third and x to the first. Well, those two are x's, so I'm going to write x, and I'm going to write 3 plus 1. Right? Times, now I'm going to do my y. Oops, didn't mean to do that. Did mean to do this. Y to the second and y to the 11th. So those y's are the same. So I'm going to say y, and then that means I can add 2 plus 11. 2 plus 11. So what is the final answer? What is this going to give me? It's going to give me x. 3 plus 1 is 4. Times y. 2 plus 11 is 13. Y to the 13th. Look at that. Look at that. That is called the product property, right? It means that if we have the same base, we can add the exponents, right? We can add the exponents. So this is what we're going to cover today, okay? The other properties, the powers property and the quotient property we'll cover next time. But today we're going to focus on the product property. Okay? So, let's look at our instructions. Always, right? Instructions say, simplify. Your answer should contain only positive exponents, right? So if we come about any negative exponents, we know what to do because we covered the properties of negative, right? And we have our notes right here. So let's take a look. Okay? Let's take a look at number 1 here. So number 1 says 3x to the third times 8x to the 9th times 9x to the 5th. Interesting. Okay? So watch what I'm going to do first. What I'm going to do first is I'm going to take all my regular numbers, just numbers, okay? I'm going to take my 3, my 8, and my 9, and I'm going to write those 3 dudes together. 3 times 8 times 9, okay? And then I'm going to say times, well, what do I notice here? X, X, X. Those are all the same base. So I could write them all as just X. And what do I do with the exponents? 3, 9, and 5. I add them, right? 3 plus 9 plus 5. So I'm going to use, remember you guys can use your calculator if you wanted to multiply these 3 times 8 times 9 gives me 216. 216. Now x, I'm going to bring it down, and I'm going to add these 3 right here. 3 plus 9 is 12. 12 plus 5 is 17. I get 17. And that right here, kiddos, is my final solution, right? My final simplification. There you go. Look at that. Look at that, right? So since I'm multiplying, right, product, and I have the same base, That means that I could write the base one time and I add my 3 exponents. 3 plus 9 plus 5. Perfect. Perfect, perfect, perfect. Let's do a second example, which is right here, right? So, what do I notice? Let's take a look here. Well, I'm going to notice my 4 is my regular number and my 5 is a regular number. So I'm going to write those two dudes together like this. 4 times 5 times, what else do I notice? Well, I notice I have an M. Oop, didn't mean to do that. I notice I have an M here and I have an M here. So that means I could write that M as just M. And what do I do with the exponents? 8 plus 5, right? So 8 plus 5 as exponents. Times, I have another letter. I gotta address that other letter, everybody. Let's address that other letter. Let's do purple. I have N here and I have N here. That means I'm gonna write N. And what do I do with the exponents again? The bases are the same, right? N and N. So I'm gonna take 5 plus 5, right? So I'm gonna say 5 plus 5. Now, let's simplify, right? 4 times 5 is 20. M. 8 plus 5 is 13. N. 5 plus 5 is 10. And there you go. Look at that. That's number 2. Simplified. You simplified it, right? Bases are the same. We add the bases, right? Regular numbers, you just multiply them because we are multiplying, right? It says times. Perfect. Okay. 2 examples down, 1 more example. Okay. So let's take a look. Again, I'm going to look for my regular numbers here. My non-exponents, so my 3 is a regular number and my 2 is a regular number. So I'm going to write those two over here. 3 times 2. Okay, now let's work with letters here. So I have a Y, Z, X, Y, Z. So I'm going to start with alphabetical order. I'm going to go with X first. So I have my X here. Okay. Do I have any other X's here? Let's see. No, Y, Z. That's just X. So this X to the 5th is just going to come down as X to the power of 5. I can't add it with anything. There's nothing else. There's no other X, right? Times. Okay. Let's do Y next. Okay. I have a Y here and I have a Y here. So those two Y's are the same, so I can just write this as Y. And what do I write with? What do I do with the exponents? 3 plus 7, right? 3 plus 7 times, I have one more letter that I haven't highlighted yet, right? I have this Z here and this Z here. And since I'm multiplying, that means that I can just write Z as 1Z. And with the exponents, I'm going to say 8 plus 6. 8 plus 6. And there you go. Look at that. Now, let's simplify. 3 times 2, that gives me 6. Right? Now, this X to the 5th, well, I'm not adding 5 to anything, so that just comes down at X to the 5th. Okay, next is Y, so I'm going to write down Y, and 3 plus 7 is 10. Look at that. Next is Z, so I'm going to write Z, and 8 plus 6 is 14. And that right there, kiddos, is my final solution. Look at that. Look at that. Right? And those are the 3 kinds of examples that you're going to see in your worksheet, right? In your Properties of Exponents Part 1 worksheet. So make sure you rewind, in order for clarification, right? But again, we're gonna cover these other. Whoa! Wait! What was? Wait, how did I do that? All right, we're gonna cover the rest of these properties a little later. All right. Thank you guys for being here. See you next time.